أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم السلام عليكم ورحمة الله وبركاته. Okay, welcome to the second part of our video on overview of what we need to take note of for our first CA in physics. Okay, I'm going to start from equations of uniformly accelerated motion. Let's say, but before we begin, I want to give this information. The values you see in this video are not going to be the exact values you will see in the CA. You only have to learn the transformation of those values to get the accurate result. Only the procedures you are expected to learn, and not to memorize those values and memorize the calculations. They are not going to help you during the CA and subsequently in the exam. So, having said that, let us begin. Let's say that we have a particle and that the particle accelerates from rest. If it started from rest, then we know that our v sub I is 0 in meters per second because it started from rest. Okay, and it accelerated, let's say, at the rate of 12 meters per second. So its acceleration is 12 meters per second squared. Okay, now the question here is what will be its velocity after 16 seconds. Let's say after 16 second time is 16 second, what will be its velocity? Clearly, so we are not given distance here, and since we are not given distance, we use a formula that has no distance to get the acceleration. Or as simply as that, what are we asked to find? Let's see that again. The velocity. Okay, the final velocity. So we use this f, v sub f is equal to v sub I plus at. Now this is equal to, it started from rest, so initial velocity is 0 plus the acceleration is 12 multiplied by the time taken 16. So 12 times 16. So I take my calculator and say 0 plus 12 times 16 and something like this. Okay, something like this. Then you now press the equality sign and your result will be 192. So this will be 192 in meters per second. 12 seconds later, its velocity will be 192 meters per second. Now, this is the first question, finding the velocity. The second one is, what if I now want to find the average speed or average velocity? So my average velocity is velocity initial plus velocity final divided by 2. Don't forget that. It started from rest, so its velocity initial was 0. So I have 0 plus the velocity final. We just calculated that and we have 192 divided by 2. So this will be 192 divided by 2, and our result, we just take the calculator and say 192 divided by 2, and our result will be 96. We will get 96. So this is 96 in meters per second. Another question related to this is, what if we want to know the distance traveled after this 16 seconds? If we want to know the distance traveled, we can use this formula. S is equal to v sub I t plus half a t squared. And then it started from rest. If it started from rest, then your v sub I is 0. The time taken 16 plus half its acceleration. The acceleration given was 12 meters per second. So times 12 meters per second squared, then multiplied by time squared, and the time was 16 squared. Right? So here, because this one is 0, so this will vanish. 0 times 16 will vanish, and I have half here is 0.5. So the rest, I'll take my calculator and say 0.5 times 12 times 16 squared, then this is equal to this will give me 1536. So my result will be 1536, and since it is distance, it will be in meters. This is how I will get my final velocity, my average velocity, and my distance covered. We have to take note of this seriously. Okay, moving on. Let's say we have a problem that says that a bus is moving in a straight line, and that it moves with a velocity of 60. This is a new problem entirely, with a velocity of 60 meters per second, and then the driver applies the brake, and then it slows down constantly at a rate of 8.0 meters per second per second. Okay, so the question here is that we should find how far it goes before stopping. You see, we don't know the time, but we know that when it stops, its final velocity is 0. So from what we are given here, we know that this is our v sub I, and this is our acceleration, because here they mentioned per second, so you have per second here, and in this unit you have per second, so per second plus this per second will be per second squared. So this is actually acceleration. Your acceleration is 8.0 meters per second squared. We are not given time, but they said we should find how far it goes. That is distance. How can we find the distance? The final velocity is 0 when it stops. So it means we will use this formula: final velocity squared is equal to initial velocity squared, okay, plus 2as, where s is the distance. Now to get my s, I will have to make s the subject of the formula. So final velocity squared, okay, minus initial velocity squared is equal to 2as. Then I divide both sides by 2a. Here 2 by 2a, this cancel this, and my s is equal to v final squared minus v initial squared divided by 2a, and this is equal to, open bracket, my v final is 0, so I have 0 squared minus my v initial was look at it, 60, so I have 60 here squared, close bracket, divided by 2 into my a. Oh, this is wonderful. Since it is slowing down, don't forget to put negative. Whenever an object slows down, the acceleration is negative, even if it is not given in the problem. So 8.0. So then the rest is, how do I get this from my calculator? I take my calculator and press open bracket, 0 squared minus 60 squared, close bracket, something like this. Okay, you have something like this. Then you divide this by 2 into 2 open bracket negative 8.0 close bracket. You have something like this. So you now press equality sign, and what I got here is 225. So it means the distance traveled before stopping is 225 meters per second. This is very important. You should also take note of this. Moving on, let's say again that we have a robot, okay, and that this robot is initially moving with a speed of 8.4 in meters per second, okay. Then it is now it subsequently speed up, so that its speed is now 16.8 in meters per second, and the time it takes for this speed to increase from here to here, from this value to this value, it takes time, and that time is 4.7 seconds. The question is, what will be the magnitude of its average acceleration? Very simple. We know that initial velocity, this is our v sub I, final velocity, this is our v sub f, and this is the time taken t. So our acceleration is v final minus v initial divided by the time it takes to change, and this is equal to your v final. Look at it here, 16.8 minus your v initial 8.4 close bracket divided by the time taken 4.7. So again, you take the calculator, you open bracket 16.8 minus 8.4 close bracket divided by 4.7. When you do that, look at what you have here. Approximately I have 1.8, so my acceleration is 1.8 in meters per second squared, approximately, correct to one decimal place. Okay, let's say again that we have a car, and that car is moving with a speed of 30 meters. This is a new problem, 30 meters per second. That is the initial speed of the car, and that the driver now applies the brake, and then it eventually stops, and the time it takes before stopping was 18.4 seconds. 18.4 seconds. So this is v sub I, and this is the time it takes, and we know that when it finally stops, your v sub f is 0 since it is slowing down. Okay, so the question here is that what is its average acceleration? What is the acceleration? So how do I get the acceleration? That is the question. I'm giving the time here, so it's almost the same formula I'm going to use here. If you look at what we have here, okay, final velocity minus initial velocity divided by the time taken. Here too, I will use the same formula. I will say my acceleration is v final minus v initial divided by t, and this it goes like this. My v final is 0 because it stopped, v initial 30 divided by the time taken 18.4 open bracket close bracket. So the rest, I will now take my calculator and say, okay, I now open bracket and say 0 minus 30 close bracket divided by 18.4, and this will give me negative 1.63. okay, negative 1.6, approximately negative 1.6 in meters per second squared. That is, the acceleration makes sense, it's negative because the car is slowing down. Okay, it has to be negative. If you don't have a negative acceleration when a particle is slowing down, please check your calculator again, check your calculation again, it must be negative. Okay, then we move on to motion under gravity. If I have a stone and this stone is thrown vertically upward with a velocity of 35 meters per second, vertically upward, the initial velocity u is 35 meters per second. Okay, the question is how long. When we say how long, we are asking about time. What time does it take to reach its maximum height? Don't forget, at maximum height, okay, let me call the v initial, and the v final is 0 at maximum height. So don't forget again that g is 10 meters per second squared. But if a particle is thrown vertically upward, your g is negative. If it is released from a height, your g is positive. In this case, it is thrown vertically upward. Sorry, this g we will be using 9.8. Since it is thrown vertically upward, we put a negative sign for the g. Now the question is how long, what time will it take to reach this maximum height? Okay, how do we get this time? This is interesting. So we use this formula. You can pretty much use this one, you see. So your acceleration becomes gravitational acceleration. You interchange this to get the time. So your time t is equal to v final minus v initial divided by the acceleration. But your acceleration is now g, so we put the g here. So this is equal to final velocity at maximum height 0 minus initial velocity 35 divided by our g minus 9.8. You see, so again take your calculator and press open bracket 0 minus 35 close bracket divided by, since this is negative we have to put it in bracket as well, open bracket negative 9.8 close bracket, and look at it, I have 3.57 approximately 3.6, so my time will be 3.6 in seconds. This is the time it will take, okay, 3.6 seconds. Now we are making progress and I love it very much. Okay, again, let's say we have a ball and this ball is thrown vertically upward with an initial velocity of 40 meters per second. Okay, a new question. Initial velocity v sub I 40 meters per second is thrown vertically upward with this. And don't forget our g, if it is thrown vertically upward, our g is negative 9.8 meters per second squared. Okay, even if we are not told, we should remember this. So the question now is, how high will it go? When we say how high, what will be the maximum height? How high will it go before it start falling back? So the question is, what will be the maximum height? The height is what? That is the question. We have two formulae for calculating this height. We can use h is equal to v sub I t plus or minus half gt squared, and we have another one that says v final squared equals v initial squared, right? Plus or minus 2gh. But this one, we don't have time here. We know that the final velocity at maximum height is 0 meters per second. Since in the parameters here we are not given time and this formula has time, we will not use this one, we'll use this one. Okay, we just put the plus sign, so our v final squared is equal to v initial squared plus 2gh. Okay, then to find h, we have to make h the subject of the formula, so we take this to the other side, it becomes negative, and we divide it by 2g, so our h is equal to v final squared minus v initial squared divided by 2g, and this is equal to our v final is 0 because at maximum height you have 0 vertical velocity, squared minus v sub I initial velocity, that was 40. So we have 40 squared close bracket divided by 2 into negative 9.84g. Again, we take our calculator. We now say open bracket 0 squared minus 40 squared, okay, close bracket divided by 2 into negative 9.8 close bracket, and then your answer will be positive 81.6 approximately. If you don't have a positive result, you are wrong. 81.6, and this is height, it should be in meters. Okay, now we are done with motion under gravity. Now we are going to projectile motion. Remember, in projectile motion, the motion is two-dimensional. You have vertical component, you have horizontal component. Now don't forget that I explained that the horizontal component of the velocity remains constant throughout the journey. Let's say this is the path followed by the projectile. It is launched in this direction, but because of gravity it bends. At any point it has vertical velocity, it also has horizontal velocity. When it is here, there is horizontal velocity, there is vertical velocity. Even when the journey ended, you have the horizontal velocity and you also have the vertical velocity. Okay, now we said that this horizontal velocity, if this one is 30 meters per second, this one is also 30 meters per second, this one is also 30 meters per second. What is changing is the vertical component. why is this horizontal velocity not changing? I gave you the reason. I say the reason is that gravity has no influence. It has no influence on horizontal motion. Gravity has no influence on horizontal motion, and this is why your horizontal velocity remain constant. Please don't forget, this one is also important. Another thing we should remember is that what is the meaning of a projectile? If we say a projectile, what do we mean? Remember, any object, the interpretation we gave is any object thrown into the sky and it is allowed to move under the influence of gravity, meaning it is gravity that affects the motion of the object. We call that object projectile. If you launch a stone into the air and it moves under the influence of gravity, then that stone is a projectile. If it is a bullet, whatever it is, if it is a bomb or any other thing, then it is a projectile. Then the path followed by a projectile, it has a name. We call it trajectory. Look at this. This is the path it follows. So this path, it has a name, and the name is trajectory. Also, don't forget this one. Very, very important. Okay. What again? Okay, I think I explained all of that. So the next thing we need to know about the projectile is that we know that there is what we call range. Okay, the range of a projectile. But before we go to the range, if a projectile is somewhere here, it has vertical distance y, you can call this y1, and at the same time it also has horizontal distance, you can call this x1. When it is here, you have again y2, the vertical distance, and then it has horizontal distance from here to here, and you can call this x2, and on and on. When the journey ended, then you have the greatest horizontal distance. This maximum horizontal distance, it has a name, and that name is range. Don't forget this one. Range is the maximum horizontal distance covered by a projectile. Don't forget that. And at what angle can we achieve this range? This is also important. At what angle, sorry, can we have maximum range? Okay, if you want this range to be the greatest, you need an angle, and that angle is angle 45 degrees. Don't forget that, please. Angle 45 degrees. The formula for range is R is equal to U squared sine 2 theta divided by G, meaning whatever value of theta you are given, double it. That is the meaning of 2 theta. So if I double 45, I will get 90. So this will now change to sine 90, and we know that sine 90 degrees is 1, and if this is 1, then u squared times 1 will just be 1, will just be u squared, and then we have our expression for maximum range as u squared over g only. Okay, because 2 theta will be 1, so we have u squared times 1, which is u squared. This is also very important. Another thing is, how do we get time of flight? The formula for time of flight. The formula for time of flight is t is equal to 2u sine theta divided by g. This is the formula we use to calculate time of flight. Please don't forget this formula again. This one, u sine theta over g is the time taken to reach the maximum height. If you double it, you get the time of flight. So this is also equal to 2t, where small t is the time taken to reach the maximum height. Okay, another thing we should remember is, how do we find the vertical component of the vertical displacement? Like here I said, at any point your projectile is, it has vertical displacement and horizontal displacement. What formula do I use to get this y? Somewhere here it has y. At the greatest maximum distance, we give it a letter h. But what is the general formula we use? The general formula is this. We obtain the formula from here. S is equal to V sub I t, since it is going up, minus half gt squared. Okay, now since it is vertical displacement, we can say this is our S is y. And then for vertical displacement, don't forget, for a projectile you have horizontal velocity u sub x, you have vertical velocity u sub y, and I say that they are not interchanged. Since this is vertical, our u should also be u sub y. And then I have time here t, since it is going up, I will give it a negative sign, and I have half gt squared. This is the formula we use to get the vertical displacement at any time. Like after 1 second, I can put time as 1 here and substitute. If I know this, I will put the value and then put the value of g, then I will know how high it is above the ground after 1 second. After 2 seconds, the same thing, and on and on. This is the general formula you need. Okay, another thing is, if I have a ball and this ball is kicked with an initial velocity u, and this u is 16 meters per second, then the ball makes an angle, and this angle is 65 degrees with the horizontal. The question is, how can I obtain the maximum height? It means you have to memorize the formula for the maximum height. It says maximum height is equal to u squared, okay, sine square theta over g, over 2g. There is 2 here, I'm sorry. Now, what is the meaning of this sine square theta? It means sine theta square. It's sine square, you open bracket, sine theta square. That is the meaning of sine square theta divided by 2g. So here I can make substitution. My u is 16, so I have 16 squared. The formula say I should square it. The open bracket, sine my theta 65 degrees, close bracket, I will have to square this again, divided by 2 into my g 9.8. I don't have to put plus or minus here now for the formula, because while driving it, I consider the plus and minus. So the next is, I will now press 16 squared, open bracket, sine 65, close bracket. This is what you should press. Okay, this, when you press this one now, next you now say, okay, divided by, you press the division operator, 2 open bracket 9.8 close bracket, and then you now press equality sign. This will be 11.83, approximately 11.8. So my height will be 11.8 in meters. Okay, this is the maximum height. Again, still on projectile, let's say I have a footballer. A footballer kicks a ball, and then he kicks this ball at an angle of 45 degrees. Let's say the angle it makes with the horizontal is 45 degrees. Okay, the question is, if the ball is in the air for like 22 seconds, this means if they say it's in the air for 25 seconds, it means time of flight, because that's the time it takes in the air. So 22 seconds. Now the question is, what is the initial speed? What will be your u? So you remember the formula for time of flight. Okay, the time of flight, t is equal to 2u sine theta over g, and you can see you have the u there. So the formula is t is equal to 2u sine theta over g. Now you have to make u the subject of the formula. How do you do that? Multiply this by this, and you have gt divided by, then you take 2 and sine theta, combine them under 2 sine theta. Now you can substitute the values. Your g is 9.8 times the time 22, so I have 22 here, divided by, then my 2, I put it, sine my angle, the angle given is 45 degrees, sine 45 degrees, open bracket, close bracket. So I will now open bracket for my denominator, 9.8 multiplied by 22, I close bracket, divided by, then 2 sine 45 degrees, and then I will now press equality sign. This will give me 152.5 approximately. Check this, 152.5 correct to one decimal place, so I will get 152.5 in meters per second. This is the initial speed with which the object was thrown. Okay, having said that, we can now move on to, we are still on projectile. Let's say we have a pilot, and this pilot is an army officer. He drops a bomb from a height, and the plane was moving with a horizontal velocity of, let's say, 1000 meters per second. Oh, this is so fast. Then it drops a bomb, and this bomb hits a target. It hits a target after 60 seconds. The question is, this is the ground. The question is, how high is this plane? Meaning this vertical height. What is it? Remember, this vertical height, you can give it y. I remember for a projectile, whether it's dropping from a height or is launched from the ground, we use this formula to get it. But don't forget, when an object is going upward, its g is negative. When it is coming down, its g is positive. So if we take this formula, we must also remember that the bomb is coming down, so we have to give positive value to our g. So this one will be positive when we take it. So our y is equal to u sub y t plus, and not minus, half gt squared. Okay, the velocity that is given here, class, is our u sub x, horizontal velocity, and what we have in the formula is u sub y. U sub y is the initial velocity of the initial vertical velocity, and this is 0 here. Okay, so we will not use this one, as it's 0 here. When it is dropping, it's increasing, and at this point it has the maximum vertical velocity. But this one, remember, we say it remains constant. So since this is 0, this term will vanish, and we have y is equal to half gt squared, and this is equal to half times our g is 9.8 times our time, they say after 60 seconds, so we say 60 and the time is squared. So we now take our calculator. Half is 0.5, so I say 0.5 times 9.8 times 60, then I square the 60, and look at what I will get, 17640. So this means 17640, 17,640 meters. This is the height of the plane above the ground. Okay, wow. Moving on, wow, we have achieved a lot. Then we are done with projectile motion. Now we can treat, now we can successfully treat dimensional analysis, dimension, and also unit conversion. Okay, for dimension, do not forget what we said. We said that all physical equations, all of them, no exception, every physical equation you see in physics, it must be dimensionally consistent. Let me write this, consistent. And what does it mean? It means all the terms in the equation must agree with each other in terms of unit. For example, if I have S is equal to ut plus half at squared, I know that my S is measured in meters. Then the combined unit of velocity and time must give me meter, and the combined unit of acceleration and time here must also give meter. When this happens, we say it is dimensionally consistent. Otherwise, it is inconsistent, and when it is inconsistent, it is wrong. Okay, so here meter per second for velocity, and then time second. When I multiply this, second cancel second, and I have the meter. Here is meter per second squared, and I have time here. The time is squared, so I have second squared cancel second squared, and I have the meter. this is number, and number has no dimension. So this is dimensionally consistent. Okay. Next, how do I get the dimension of density? For example, if I want to get the dimension of density, and then I will say, okay, my formula for density is mass divided by volume. So I will combine the dimension of these two physical quantities, and this is equal to the dimension of mass is capital M, the dimension of volume is L to the third power. So I will rearrange this as ML minus 3, and this is the dimension of density. This is very important also. You should take note of this. What of force? If I want to get the dimension of force, God, I love force, and this is equal to mass times acceleration. Mass times acceleration from Newton's second law. So I will now combine the dimension of mass and acceleration. Mass is capital M, and then for acceleration is LT minus 2. If I combine this together, the dimension of force becomes MLT minus 2. Okay, also don't forget this. Okay, do not forget this. Now there are some physical quantities that we say they have the same dimension. Let me list them. We have Young modulus. Young modulus. Some people say modulus. Young modulus is wrong. It's Young modulus. Okay. The next one is pressure. Pressure. And the final one is stress. Don't forget, these three, they have the same dimension, and because of that they have the same unit. Each one is Pascal, or if you like, Newton per square meter, Newton per square meter, Newton per square meter. Okay, great. Don't forget this trio of physical quantities with the same SI unit. Now there is another formula, Bernoulli's principle, H rho, P plus rho GH plus half rho V square equals K, where this P is pressure. Okay, the P we have is pressure, this is density, this is acceleration due to gravity, height, density, velocity, and then this is a constant. The question is, what will be the value, what will be the unit of this constant? As simple, the unit of the constant should be the unit of pressure, because pressure is added to this, so this one also must have the unit of pressure, Newton per square meter, and when you combine this, the unit must be Newton per square meter. This one also, the unit must be Newton per square meter, and since we are equating it to this, the unit of this must also be Newton per square meter. This way it is dimensionally consistent, otherwise it is incorrect. So the unit should be the unit of pressure, which is Newton per square meter. Now, having said that, we can now consider unit conversion. Let's say I have a speed of 180 kilometer per hour. How do I change this to meter per second? Very simple. You said this is equal to 180 kilometer divided by 1 hour. Okay, and this is equal to 180, then you multiply this, kilo mean 1000, so you have 180 times 1000, and 1 hour is 3600 in second. Now you have it in meter per second. So here, just take your calculator and then you open bracket and say 180 multiplied by 1000 close bracket divided by 3600, and your answer will just be, wow, 50. So this means this is 50 in meters per second. Please don't forget this. Okay, this is how you convert. Numerator 1000, denominator 3600. That's the general way of doing it. Then let's say I have a speed of the same 180, but now it is in mile per hour. How do I change this one to meter per second? then this should be the unit factors. Let me give that. Your mile is 1 mile. Every 1 mile is 1.609 in kilometer, and don't forget again, every 1 kilometer is 1000 meter, right? And then every 1 hour is 3600 seconds. So these are the conversion factors. The first thing you will do is to say 180 mile divided by 1 hour. Okay, now next I want to change mile to to uh, mile to kilometer. So I need mile here, so I will bring mile down here, 1 mile, so that it can mile can cancel mile here, and then the numerator I will put 1.609 in kilometer. Next I want to cancel this kilometer, so I need kilometer down here, so I will take this 1 kilometer, and then the other one I will put it here, 100 meter. Then finally, if I do that, you can see that from here my mile cancel mile, and then again kilometer cancel kilometer. So I have converted mile to meter. You see, I have converted mile to meter. Then how do I change this hour to second? In the next bracket I do that. I will do that in the next bracket. In the next bracket here, since hour is under, I need hour on top, so I will take 1 hour here, and then the other one I will bring it down, so that 1 hour that I have here can cancel the 1 hour I have here, and I have second here. So at the end I will have meter per second. So what I will do now is I will take my calculator and say 180 times this one, 1.609 times 1000, that is what I will have in the numerator, and then divided by, in the denominator, what I have, everything cancel, I only have 3600. Now is in meter per second. So I will simply take my calculator and say, open bracket, 18, let me cancel one of the zeros here, 180 multiplied by 1.609, then multiplied by 1000, close bracket, then I will say divided by 3600. If I do that, look at what I will have, 80.45. Wow, so my result will just be 80.45 in meters per second. This is interesting. Then unit conversion again. Let's say I have a power value. This power value is 7500,000 in watt, and I want to change this one. This is I want to change this one to megawatt. To megawatt. What do you mean by mega? Mega is a million, and a million is 10 raised to the power of 6. How do I change this one to 10 raised to the power of 6? Look at it from here. You can do that as quickly as possible. Your decimal point is here. Since the power is 6 here, you have to move backward 6 times. So let's see that. 6 places. 1, 2, 3, 4, 5, 6, and I will have 7.5. All the zeros vanishes, and the symbol for mega is capital M. So I have capital M, and I have the symbol for watt. This is 7.5 megawatt. I hope this one is clear. Just the power of 6 here, you move backward if the power of 6 is positive. But if the power of 10 is positive, but if it is negative, you move forward. Okay, let's say I have frequency. I have a frequency, and the frequency value is 800,000,000 in hertz. In hertz, that is my frequency in hertz. Sorry, this is Z for hertz. So the question is, how do I change this one to gigahertz? To gigahertz. Okay, giga is 10 is after million. When you multiply by 1000, you have giga. So if I multiply this by 10 raised to the power of 3, I will have giga. So giga is 10 raised to the power of 9. 6 plus 3 is 9. So if it is 10 raised to the power of 9, then what I did here, I will have to repeat it. The only thing is that since I have 9, I will move 9 places backward. So my decimal point is here. So I start 1, 2, 3, 4, 5, 6, 7, 8, 9. I have 8.0, or equivalently just 8. So this will just give me 8. Giga is capital G. We use capital G for giga, and then the symbol, the hash, is capital H small z. So this will be 8 gigahertz. Okay. Finally, if I am given electricity value as 940 milliamperes. This is common in electronics, very small electricity values. How do I change this one to ampere? The question, how do I change this quantity to ampere? Okay, what you should do is this milli that you see, the milli that you see here is, it means 10 raised to the power of minus 3. So you simply move on and say, okay, this is 940 times 10 raised to the power of minus 3. It is now in ampere. The symbol of ampere is capital A. When you put this 10 raised to the power of minus 3, you can remove the milli because it means 10 raised to the power of minus 3. And at the end, you have amperes. The symbol for ampere is capital A. So you just bring the capital A here, and this is your milli, this is your 940. So the rest is, well, how do we express this in decimal form? We simply say, okay, take your calculator and press 940. After pressing 940, just press this one. Look at this, exp, exponential. And when you press, okay, let me do that again, 940, you see the 940 appears. Then press exponential, and you see times 10 appears. When you press exponential, you will see times 10 appears. Okay, then you now press the power of 10. But this power of 10 has a negative sign. Which negative sign do you press? Is it this one or this one? Can you see? Is this one that you need? Someone told me that this one also gives the same result, but my friend, this is the one that is used for exponential. So just rely on this, and then you press this one. When you press, you can see that the minus sign appears. I want to show you, you see minus sign appears. Now you can press the 3. You see, now you can press the 3, and you see you have everything. 940 times 10 to the power minus 3, and now you can press the equality sign. When you press the equality sign, you have 0.94. So your answer is 0.94 in ampere. Okay, with this we have come to the end of our overview, okay, of all what we have done. I wish you success in this test, inshallah, and also in the exam as well. Please study well, and you have my blessings. Assalamu alaikum wa rahmatullah.